Okay, we were talking about exhaust valves, so we shall continue talking about exhaust valves. What can you tell me about exhaust valves?
They kind of look like intake valves.
They kind of look like intake valves. He is absolutely correct.
They let the exhaust out of the cylinder.
That also, they let the exhaust, also correct. We've learned a lot.
They wear out faster than the intake valves.
Ooh, nice one. They wear out a little faster than intake valves, or actually a lot faster. What else we got?
Green is bad. Yeah,
Green is bad is very good. Green means stop.
Smaller head
Means
with a larger
Smaller head and
larger.
larger stem. Okay. That was all pretty good. Let's see. Just a few more points here. They are designed to rotate. Designed to rotate. So due to uneven cooling, if the valve didn't rotate, it would burn faster. Due to uneven, if valve did not rotate, it would burn faster. So it's got to rotate. Lycoming and Continental each have their own ideas about how a valve should rotate, how to make it rotate. They don't have different ideas about how it should. It just goes in a circle, and they both agreed upon that. So your engine has obviously the Lycoming way of doing things, and you notice your exhaust is different than your intake, right? How it was held in there. It has those half moon clips rather than the kind of the taller clips, the half moon clips. They go in there, and then you had a little cap that went on top of that. That's called a rotator cap. And without all of that stuff on there, the rocker arm and everything else, but you have your valve in there, and you have your valve springs and everything, right? That valve spring puts tension on the valve and the keepers, right? So the valve spring seat comes up, hits those keepers, pulls up on the valve, and it's loaded up. And if I ask you to turn it, like, hey, put some pliers on there and try and turn it, you'd have a hard time because the whole valve spring and everything is all kind of holding it together, right? So if to turn it, you'd end up having to turn the spring. So that makes a problem. So Lycoming puts that little tiny cap on it. And what happens is that cap actually goes down when the rocker arm comes down. It pushes on the cap. The cap pushes on the little keepers and unloads it. And allows the valve then to rotate. So it unloads it from the springs and allows it to rotate. Now, Continental has a different idea. And I just remember that I do have one in here, I think. Boy, it did far out too. Hey, I got it. Oh, this thing. Hide behind something. Continental uses roto coils. Now, on the much more expensive Lycoming engines, they will put that rotator style on intake and exhaust, which is rather exotic with some of the stuff they do with Venturi seats and big old intake valves. But Continental, they use what's called a roto coil. So it's kind of a two-piece deal where it is allowed to turn. These wear out, so I've never taken one apart because they're stamped together. I should take one apart, but always when I had them, I'd always lubricate them, make sure they rotate. But so the valve comes up, keepers go in there, and then its valve can rotate while the spring is right there. So I'm gonna pass it around.
Sure.
Sometimes I hate it. Teachers like, pass it around. I'm like, God, now I gotta look at the person behind me. I hate that. Okay.
I don't like looking at the person.
Then you just toss it. Let's see. Rotator caps. Okay, yeah, so we have the rotator caps. So we'll put one to rotator. Rotator, we'll call them rotator caps just because I can. So we'll say, we'll do that. Rotator caps is for Lycoming, and roto coil. That's our roto coil. That's Continental. All right, now we can talk about the intake valve. The intake valve. The intake valve
Kind of looks like the exhaust.
kind of looks like the exhaust valve. We are learning stuff. All right.
Same stuff.
Intake valve. Well, that's cooled by the fuel air. Cooled by fuel air mixture coming in. So it's already got semi-cold air and the fuel coming across it. So that stays reasonably cold. So don't really have a lot of problems with that particular valve. Definitely has a larger head. Larger head than exhaust. Why would we put a larger head on the intake valve?
To let more fuel air mixture.
More fuel, so that creates better volumetric efficiency. All right, the exhaust valve. I drew that beautiful picture, which I don't think I have anymore. Let's see. Oh, I did. Right there, we've got the face. What degree? How many degrees is that face?
45.
The exhaust is 45. And now if we talk about the intake, now old-timey intake valves will also be 45, but all new or modern engines, you know, anything made in the last, say, 70 years, will have a 30 degree. So newer, I hate to say newer because I'm really talking 40, 50 years ago. So we'll just say 30 degree face. 30 degree face. Unless it's really old. And it would be 45. Let me see.
Like what decade?
What's that?
What decade?
1960.
You'd have to go way back. 40s? Engine built in the 40s. I think anything after that would not. Let me see. I'll just stick with it. I have valve dimension. Oh, okay. So this is all about this. So that's all I'm going to say about the intake valve. It's 30 degree face. And then I've told you they don't. Most of the time when I overhaul the cylinder out in the shop, reuse the intake valves almost all the time. Unless it was a true engine overhaul, then I'd just put in new valves. Because honestly, the intake valves are really cheap, comparatively speaking. So, but yeah, they last a long, long time. So valve dimensions. Let's see. All right. So when I was deciding whether or not to reuse a valve, just to be very honest with you, I told you I took a measurement up near the tip, just underneath the keeper, where they never see a guide, they never wear, nothing touches it. So that's your standard dimension right there. And then you could just run your 0 to 1 micrometer down the stem. If I saw more than a thousandth inch wear, then I would just reject it. Honestly, I mean, that sounds terrible, but the book says 2. So by the time you get to 1, a little over 1, then you can actually start to see some of the chrome flashing on them start to wear out. And you can see the different colored metals below it, I would notice. So I would just throw it out. The book does say if reused, because we have to worry about stretch. So stretch, S-T-R-E-T-C, stretch is checked with a radius gauge. So you'll have a radius, and then you will just check that radius with the radius right here. If that radius is good, then there you go. And you can see even this one, it's like all stretchy looking, got some stretch marks. It starts to neck down right there. So you got to really watch that. Even though you may get a good stem out of it, if it's all neck down right there and this thing is stretching out, you can have a failure right there. You guys haven't noticed, you know, the shelf in the lab up there, there's a bunch of stuff. Take a look. Sometimes there's a piston up there with a valve face embedded in it. That's just not something I found. That's Larry's. And he did that. So he made that. His valve came apart and stuck itself inside of a piston. Valve keepers, let's see. Valve keepers, usually not reused. I'm just putting not reused. They're really cheap. They're supposed to be replaced. It's like, why bother? We already.
With that valve embedding itself in the piston, you're obviously going to notice that right away. So is that just, where's the airport and
Yeah.
take the engine off and overhaul?
Where's the closest field?
You know, a 6-cylinder, I've never lost a cylinder, but in a 6-cylinder, but they'll run a little better. I mean, I've run engines where one cylinder's out of the 6, it's not firing, you know, the fouled spark plug, and you don't notice it. I've heard a lot of people say you don't notice it that much. You see a little loss of power. 4-cylinder, you just lost 25% of your thrust, so I think you'd notice it a lot faster. Let's see. Keepers, so we may be of the rotator type. Let me see. Oh yeah, this is, I think, a Q&A question. So radial engines. Radial engines, most of the time, use a circlet, which is just a fancy word for a...
Snap ring.
Yeah, thank you, snap rings. But some of them, they don't even have, you know, snap ring, you have snap ring pliers, you have little holes. Okay, a true circle doesn't have that. It's just a piece of wire bent like that. There's no, the only way you can get it off is, you know, kind of pop it off. There's no tools. Tool's a screwdriver. So radial engines use a circlet. Where am I? On the valve. To prevent the valve from falling in the cylinder, to prevent valve. I don't know. It's still going to fall in the cylinder, but if it's upside down, it's going to go this way. So I shouldn't say that. To prevent the valve from falling into the cylinder if the keepers break. So I don't know. I'll just go with it. To prevent valve from falling into cylinder if keeper breaks. I really don't know why they do that. Maybe there's a different reason. I can't think of it. So here's a radial engine, and by the way, look at the keeper grooves on that. Instead of having a groove where you just have like you guys have on your intake, I mean, it's got a bunch of them. Those keepers really, I mean, they got a bunch of grooves in it. Go right down there where that groove is. That's where that little spring circlet goes. Just snaps right there. So you put it in the cylinder. Got to put that on. Stack the valves. Put the keeper on. Let's see, valve guides. I think I could abbreviate some of this. So, installed into the cylinder head with an interference fit. What does that mean? The guide is bigger than the hole. So to get it in, you have to hit it real frickin' hard. You gotta heat the head, cool the guide. Let's see, interference fit. Okay, interference fit. I want to hit just some big points in here instead of a bunch of stuff. So I wrote, intake made of various softer alloys, brass, bronze. The exhaust then would be made of harder alloys, steel. That's not really important for you to know. I will put this one though. Let's see. Never mix and match valves and guides. By that I mean use the same manufacturer. So if I'm going to get a superior valve, use a superior guide. If I was going to ECI valve, use ECI guide. You're going to use a factory valve, use a factory guide, because they actually make their valves and guides out of different materials. They have different ideas how to do it, and they aren't always compatible. I don't think you're going to get this catastrophic failure, but it just won't last as long. One thing's going to wear when it shouldn't have, so always use the same manufacturer. I mean, it's huge. It's just like, well, what do you do if you're out in the field and you have to replace a valve? Well, take out the old valve and see if there's a part number anywhere on there. If it's intake, there usually is. Hope there's a part number on it. Usually exhaust, you're not going to get it. And order that one. If that doesn't work, look at the guide. They do have part numbers on them. You just have to get a flashlight and get down in there and look. And there should be a part number on there. And once you get the part number, you'll know who made it. If it had a LW or a 13 Sierra number, LW, or was I think 13 Sierra is how they started those, then that would be a Lycoming. If it had SL, that would be Superior Lycoming part, or SA for Continental. ECI was, I don't remember now. Had the L and the A, I think. It was ECL. I don't know. Huh? AEL, that's it, AEL. AEL and AEC. Yeah, that looks right. So, let's take the part number. Let's see. Oh, I like this one. Let's see, as guides wear, WE wear, especially the intake. And they don't wear very often. Oil consumption will rise. Why? Because I didn't ask why. Don't tell me. Let's see. Let's find a picture of a cylinder. Is this one going to work for me? Why not? Make it work. All right. So this is the intake port, and the valve opens. The intake valve opens, and the piston is moving down. It creates a low pressure right here to pull in the fuel air mixture. There's a low pressure here. There is a low pressure here. So this is all low pressure. This up here is high pressure. There's oil up in here. So if this is a vacuum and you have space between the guide, then the vacuum will travel up here into this guide and suck the oily mess right down inside that valve. So Continental, on all of their big bore engines, they have a guide seal, intake guide seal. In fact, I remember when they kind of came out with them. Well, they had them for a while, but they eventually came out with the service bolt and said, all right, we have it on some engines, now we want them on all engines. So I did a lot of them, just a little cutter. And I put it on there, and you have to cut the guide down and put the little seal on. So I remember when they didn't have them. All right, we'll rise. We could put some intakes. Have oil seals. Let's see. Let me see. D, alignment is critical. All right. This is a hard one. So we have, this is going to be terrible. I'm just going to warn you. We have a seat inside of the cylinder. All right, half the seat. All right, maybe I can use this without drawing and making myself look stupid. So we have a seat inside of a boss. You have so that seat could potentially, the boss could be off a little bit one way or another, thousandths of an inch one way or another. Then you put the seat in. Then you grind the seat. Well, you could be off a little bit on that. Then the valve has to hit the seat. But the valve is inside of a guide. The guide has a hole that's been bored in it. The guide goes into a hole that has been bored. So we've got 1, 2, 3, 4, 5 different ways that could be screwed up. You follow so far? So guide's got to be in the right position, and the hole in the guide's got to be in the right position, and the seat's got to be in the hole in the right position, and the seat has to be in the right position. Okay, now we're going to compound that. We got all of that, so that could put this valve going any kind of which way, and misalignment here. Now you've got 4 bushings up here, which have the rocker arm going all kinds of different ways. Then we're going to put a rocker arm that's going to go on here that has a hole in it with a bushing in it that also had to be bored correctly. And that could be off this way or that way, which is all to say that all of this could go any which way and be off. And once you get that alignment off, then you're kind of screwed. Now, I know some people who, because the valve's supposed to stay still or rotate.
Rotate.
Rotate. So I know some people who take the rocker arms and it's supposed to hit the valve square on. They'll grind it so it hits it like this. And they go, oh, well, that will turn it. Well, what do you think that does? Side load. Every time it pushes it over that way, pushes it over that way. Okay. So here's the funny part.
But that, I'm assuming that would also cause a lot of damage to the guide as well.
You're going to wear out the guide, wear out the valve, won't hit the seat right. You're going to get a bunch of leakage. So what's the fix? Well, you got to fix everything. Okay. So here's my major mistake. Learn from me. All right. So you want that rocker arm to come down and you want to hit it perfectly square. And so that's where my little Bic pen came in. Put the little Bic pen, so you put it all together and you take the rocker arm and you put it down and then you use a little Bic pen and go back behind there, my shine light, and get down there, make sure that rocker arm would hit it just perfect. Because boy, you get just a little tiny bit of light and that's going to put a little side load and eventually that's going to cause wear. So, I didn't want that to happen. So all of my cylinders were like perfect, right? And so we would often get rocker arms and people would do I would do kits too for people who want to do their own engines. They're like, no, I want to build it. And I'm like, fine. They bring their whole engine in. I would do the non-destructive testing, do all the machine work, order the parts for them, put this whole kit together and just hand it back. Go, hey, here's your whole kit. You just go home and put it together like a Lego set. I like doing that. One day, though, we were working for somebody who he was a fictitious litigator. You know what that is?
What?
Fictitious litigator?
Oh, fictitious.
Somebody who sues everybody. You guys don't remember Sacramento Sky Ranch, but they were like Aircraft Spruce local. They sold everything. You needed anything in this town for aircraft, you went over there. You saw Johnny Schwanner and his dad. Yeah.
Talk about on Freeport?
Yep.
We're still there?
Well, not. It says Sacramento Sky Ranch, but it's like a
Oh, okay.
gym for kids or something. And yeah. Well, I mean, back in the day, they did engine overhaul, hoses, sold every kind of part. You just go down anything you wanted. They'd get it, right? They had a direct vendor for Lycoming, Continental, all the oil, books, right? Do you guys know Aircraft Spruce is? I mean, these guys, they were just Aircraft Spruce. Aircraft Spruce kind of came out when the internet did and put them out of business. But anyway, so the story was he had actually bought like some sort of fuel control for his, and it came in a brand new Continental sealed box, and something about it he didn't like, and he sued them over it. He sued Continental over it. He was just one of those guys. Well, he had brought some stuff in, and I guess I'm making the story much longer than it has to be, but I had overhauled his rocker arms, and somebody else in the shop had did something with the crankcase, but he didn't like what they did with the crankcase, and it was an old crankcase that had been superseded, and everybody knew that you wanted the different newer one because they're much stronger. And somebody did something to his crankcase, and he was kind of mad about it. So he brought it in to the boss, and he's like, I want a brand new crankcase because I don't like what you did here. And the boss is like, yeah, I'm not doing that. So I don't know how he knew this, but he took the rocker arms to the FAA office and laid them on the desk and said, they overhauled my rocker arms. And the FAA was like, so? And he's like, they ground the feet. And I had this fixture, so if you didn't bring in your engine, I had this fixture. When we rebushed them, I'd make sure that it was perfectly square in alignment, so you didn't have any, And so the FAA called me up, and they said, you know so-and-so? I'm like, yeah, I know so-and-so. Well, did you overhaul his rocker arms? Yes, I overhauled his rocker arms. You have the tag in front of you, I'm sure, if you're asking me these questions. Yes, I do. Well, let me ask you something. Yeah. You reground his feet. Yeah, in fact, I have this fixture, and I make it's perfect, and I make sure they're all square. Nobody else in the industry does that. In fact, I even modified our machine so it's got these little bushings and bearings, and I can custom adjust it and make sure everything is like, yeah, that's fantastic, Kevin. Where's your data for doing that? So it's in the overhaul manual. Oh, what page? I'll get back to you. Go get the overhaul manual. Oh crap, I can't find it anywhere. Obviously, it's in this one. I know I've seen it somewhere. I'm going through manual after manual after manual, going, oh shit, I can't find it anywhere. So then I start, calling some of the people I work with, other shops, like competitors, but we all work together, right? They can't do something, I call them, back and forth. So I called like 3 shops. I'm like, hey, you guys overhaul rocker arms? Well, we do. You guys reface the feet? Hell yeah, we do. What's your data for doing that? It's in the overhaul manual. Yeah, that's what I thought, but I can't seem to find it. Well, I'll call you back. And then, I call all these places, then pretty soon the phone starts ringing the other way. Dude, Kevin, we can't find it. I'm like, yeah, I can't either. And so eventually I call my shop, ECI, who we did so much work with up in Oregon. And I'm like, hey, you guys reface rocker arms? Yeah. It's not in the overhaul manual? Yeah, we know. We have a procedure for doing it. I'm like, oh, can I see that procedure? So they faxed it down to me. And so I called the FAA back, and I'm like, hey, look, here's the deal. Explain kind of, I've called everybody. We all thought you could do it. I'm like, I even learned how to do it in A&P school. When I took over here in the shop, they're like, this is how you do it. I was taught how to do it. And they're like, yeah, we kind of figured that too. So they're like, yeah, we were shocked too. In fact, even the FAA guys, yeah, I used to do it all the time too. He goes, I had no idea. So he's like, I tell you what, we're gonna have to do something about this, but I'm gonna give you 30 days to do something. So let me know what you come up with. So during the next 30 days, I wrote a whole procedure for refacing rocker arms. And so it involved, you could reface it. Then I had to get some data, and then got a Rockwell hardness tester. We test the hardness of the feet. Then I had a little comparator gauge where I would see the surface finish and do it, and I wrote it all up. This is like before computers, so I had to write it, take photos, have the photos printed, tape them into a book, and then put it in a color copier. That took more time than anything. And then I took it on the FAA, and they looked through it. This is really nice. Approved. So they went back to the guy and said, we went down to investigate. They have approval to do it, man. I don't know what to tell you. They knew who he was, too. Big old fat guy, I remember. The shop was so mad at him. The funniest thing ever. One of the guys, well, this is part of the story. He's a big old fat guy. One of the guys in the shop's like, yeah, don't worry about it. I just signed him up for Bacon of the Month Club. He'll be gone in a week. Not nice. Hopefully none of you know who I'm talking about. I think he died finally, but anyway.
Stop that energy. Stop that.
I'm not bitter or anything.
Yeah.
Anyway, so I guess I tell you that story to tell you, I screwed up. It does happen. So what is that called? Dirty Dozen? Complacency. Not so much complacency. It's complacent enough that I didn't check the manual for myself. So yeah, I was complacent in the information I was given. Like, I don't need to check. But definitely called the norms. Yeah, that's the norms.
Yeah, everybody taught that.
I was taught it in this school. And I showed up, and they were doing it when I arrived. And then we bought all this equipment from Sky Ranch, and the expert of experts came in, and I even think in the Sky Ranch engineering manual, I'm looking like this because it's in my office. I think even talks about it in there. It's like it's everywhere, and then suddenly it's like, oh, but it's really not. It's not in the manual.
The procedure that you did before you wrote up the way you do it. Were they the same, like, quality? Same thing. Yeah.
Didn't change a thing. Only thing I added was doing a Rockwell hardness test, which was just pointless because they were fine. But so we did it. Now, so since we're on the subject of rocker arms, which I will get to later, here's the funny thing then. You're not allowed to reface rocker arms. So they have this you have to, I didn't bring one in. If I did, it'd be small. But the little face that kind of wipes on there. They're angled, so it goes like this. But look at them. You know, they get dents in them, they get scratches in them, they're wear. And so it's not in your replace. They're expensive. And you don't normally replace them. You just rebush them. So it's like if you read the manual, what you're supposed to do is measure the bushing, and if the bushing's good, throw it back in. If the bushing's bad, replace the bushing, throw it back in. And so here you have this brand new cylinder worth, geez, Larry just priced these out. I think they're $1,500 a piece. And that's the smallest ones, if you can get them. So you got a cylinder, not labor and everything else. You're, I don't know what, $3,000 per cylinder if you figure labor. And you're just supposed to throw some old rocker arm back on there that doesn't line up to the valve very well. It's like, I don't want to do that. So the whole thing is crazy. And then if you send your rocker arms out to have them done and they come back, there's no guarantee that they're going to go where they go. So, I mean, I literally would set all my cylinders up on the table, and I would put a rocker arm in the rocker shaft. I would say, okay, now I'm building up my cylinders. I put the rocker arm in, get down there with my light, and I'd figure, okay, this one is, it's hitting over on this side, so I got to grind a little bit over here to make it flat. I take it over to the rocker arm refacer. I would do just a little adjustment. So I'd take a little bit off at the bottom, and I would get it till it's perfect. I'd bring it back over, check it. Okay, that one's perfect. No light at all behind it. Okay, now on to the next one. Readjust the machine so every single part was custom fit to that particular cylinder for its idiosyncrasies. Because, we're only talking about half a thou to one at the most. But anyway, you can't really do that. That's, for the most part, illegal to do. You're just supposed to throw them back in there and go, well, there you go. Sorry about your $200,000 engine that's, got crappy rocker arms. You're going to wear your valves out. All right, I'll get off my soapbox. But it's just kind of weird that's the way the engine manufacturers go with this stuff. See valve guides. Alignment is critical. Yeah, it took me a while to say. Yeah, A, B, C, D, E. We talked about this one. Exhaust guides, your exhaust valves are prone to sticking. That's why I talked about morning sickness. Larry's going to talk a lot about this with you guys when he gets into inspections. But ultimately what happens is the exhaust valve will seize itself up inside of the guide. Now, if the valve is closed, then that means it's going to be up this way the most. And when the camshaft comes around and pushes on the tappet, which pushes on the push rod, to push on the rocker arm to push it down, and it doesn't go, something has to give. Most of the time, it's just the push rod, and the push rod housing will bend out. You pull the cowling, and you're like, oh, there's my problem. You got your tubes that are supposed to be straight, one's lower like this now. That's best case scenario. Worst case scenario is it chips the a tappet body, or tappet face, and they're easy to replace. All you have to do is take apart the whole engine, put a new one in. So, yeah, no thanks. Unless it is the Continental. Here's my Continentals.
Some because you can change them from the top.
They're on the bottom. Continental's on the bottom, but there's no.
Oh.
So this ain't coming out the engine that way. This goes in, and you just tap the plier and pull it out. There you go. Check it. If you don't like it, if you don't like what you see, just put it back now. So you change those out.
Flip it over.
Yes, flip it over. Okay. Let's see, valve seats. They are an interference fit. Which means the seat is bigger than the hole that it fits into. Again, only changed when worn. and they don't wear. You can reface them over and over and over and over, so there's usually not much need to change them. Sometimes you have to. May have an interference angle. All right, so the angle will be off. Angle off by 1/4 to 1 degree. So if you have a 44-degree valve, then you would go, and I can't remember, if you have a 45-degree valve, I don't remember if you go 44-degree seat or 46-degree seat. I think it goes backwards. I never did it. And I'll tell you why. Because when you're refacing a seat, and I've already shown some of you, I'll show the rest of you, you're using a stone that you put on a fixture where you set the fixture to 44, and it's got a diamond stone. You spin this thing and you cut it back and forth, you get that to 44. Then you take it over the cylinder and you're going to drop a mandrel down in the guide, and then you have to put this stone over the guide, and you're going to spin the stone. Well, that has a little bit of slop in it. So if you think you're getting it dead nuts accurate, 45 degrees, you're sadly mistaken. By the time you get it from the tool cutter over to that, grind a valve, go to the next one, you're off by at least 1/4 to 1 degree anyway, so you're going to put it in no matter what. Maybe that's just a bad thing to say, but it's just true. So seats, and I tried to explain this to you when I'm showing you the cylinder line. So here's a seat, okay? So just looking at one half of it, obviously. And this is where the valve should be seated. You want the seat to be a certain width. And what I like to do is when I'll put the valve in and I'll lap the valve in. And I'll help you guys do that regardless of when you're ready to put your cylinders together, I'm going to help you do that. But I want this to be, when you lap it in, you're going to end up getting a line that goes around it. And I kind of drew what I want right there, which you probably can't see real well. But it's kind of in the lower third of it. So if this were the valve, I'll pretend like it's the valve, I'd want it to be, we'll do the valve. So here I go, I got the margin, I got the valve like that, stems goes up. I'd want it to be like right about here where it seats. Got a little bit of space right here, more space up here, so it's kind of here near the edge because I want to cool this down here. So that's pretty much where I like to see it setting. So we take the valve seat, reface it with the stone, and I'll show you how to do that. Then we put a valve in the cylinder, and we put a little lapping compound, which is just grease with sand in it, and we spin it in there, and that creates a little line here where it's touching the seat. It creates a line on the seat where this touches the seat. We can take it out, wipe it off, and see how everything's sitting together. Right? It's one way to do it. And sometimes these seats get too wide. You can just look at it and go, whoa, that's too wide. I need to narrow it. Or you can look at the valve and go, wow, this is touching way too much of it, or all the way down here. I need to fix that. So if for some reason I looked at it and it wasn't like that, and maybe it's seated all the way into here, that tells me the valve went down too much into the seat. And this valve seat is way too wide. We'll say that this one's a 45 degree. And so what I need to do is I need to cut a little bit off the top right there. So I call that topping it. And so if I took a 30 degree stone, bam, I can cut the top right off that. And if I cut the top off that, then it takes this over here where it was setting and moves it back a little bit. Follow? Or if it was the other way, I could use, it's 45, 70, 75, and cut this off like that. And that gets rid of that. And that moves this down this way. So you can manipulate your seats. If it was a 30 degree seat, then we would top it with 15 and bottom it with 45, something like that. Right? Follow? So I'll try and explain that when we're over there, but it may not be convey well. But
We would do that to help with cooling. You said cooling?
well, you want it to sit right on the valve.
Okay.
So if it doesn't sit right on the valve, I got to move the seat around.
Seating. Okay.
Follow?
Follow.
Yeah. So what if it doesn't? If the valve doesn't sit right on the seat, then it either won't cool well or won't run well. If I get too wide of a seat, I think I told you guys yesterday, what happens if the seat surface area is way too wide? There you go. There's not enough pressure because it's such a wide seat. When it comes down, it doesn't build pressure up. It doesn't want to seal well. If you get a little carbon in there, it doesn't want to knock it out real well. Yeah, that doesn't make sense, but yeah, you just don't get good seating. All right, valve seats, 3 angles. The funny thing is, you know, I've heard people talk about, you know, this, you know, building of engines and stuff. It's like, oh man, my seats, you know, I 3 angle seats, and they claim that it's like really good for volumetric efficiency. You kind of agree with that. I've heard it before, but yeah, 3 it's like a big deal, you know. And I'm like, it's a big deal? I don't know. To me, it's just making it, you know, sit right on the valve. But some people say it's a big deal and it increases gas flow and it works much better. I wouldn't automatically do that if I didn't need to. If it sat right on the valve, I wouldn't. But we also get, we have weird valve seats. One of the valve seats, instead of being square like that, it now comes in like this. A Venturi seat. And I don't know, they make a Venturi out of it. I don't know what they're doing. To me, that just kind of chokes it off a little bit, but it creates this little Venturi effect in there, which is kind of bizarre. We also have 2 different types of seats. We have this is the whole seat. Square ones, you know, with the hole in the middle. It's kind of hard to draw a circle, but the edge is square. And then we have Allison cut seats, which here's a picture. An Allison cut seat's not square. It's stepped. It's stepped. So, and I was trying to remember which way the step goes. I think it's that way where the cylinder is, but this will make more sense if I can show you this. Is this an Allison? Yeah, it's an Allison cut seat. So this is an Allison cut seat right there. Let me enlarge it. These are kind of interesting. So instead of being a straight cut, like I said, where it would just come up square like that, follow? I can't draw it because I made the screen big. You see what I'm saying? This is called an Allison cut seat. And so this area right here is an interference fit. This area is not. And I believe the whole design behind that was to eliminate cracking because of the expansion rates here on the surface of the cylinder. It would be dissimilar metal, would cause cracking on the seat. They left a gap right there for expansion and then pinched it back in here.
How much of a gap?
Very small, like 1,000 or 2 at the most, I believe. All right. I also guess that was one of my notes. I just didn't realize that. So I wrote Allison or straight cut seats. Let me see. Oh, what number am I on? A, B, C, D. Maybe Allison or straight. Valve springs. Oh, I got a great story about valve springs. It'll take me about 5 minutes to tell it.
Do it.
Unfortunately, well, it's the same group of people always for most of my stories because I worked with people for a long time. Yes, it's the same person who did the valve cylinders for the airplane with the smoke on. Unfortunately. So I was working on a Cessna 140. Well, I love the Cessna 140s. Kind of really learned to fly in a Cessna 140. The 1946, 47 was the good years. And they came with a Continental C85. small bore Continental. So the C85, 85 horsepower, would be just a little bit smaller than an 0200. So I was doing an annual on it, and I did the compression check, and we had one cylinder was really bad. So I took the cylinder off, and I walked over to the cylinder shop, gave him the cylinder, please overhaul my cylinder. He did my cylinder. And then I did the annual, and I don't know, I may have put the cylinder back on. It may have been the other mechanic. I don't know. We get the cylinder back on. And did the run up, ran perfectly. I mean, just ran so nice. And did the annual. And this didn't have the 85. It had been modified. It had the Continental 0200 in it. So just a little more horsepower, the high horsepower version. So customer comes to get him. He was a young kid. I wish I remember his name. Real nice guy. Came and got the plane. Flew it home. Called me back a day or so later. Says, man, I got a problem with the plane. He says, you know, on the ground it runs up real nice. I mean, full power, makes full power, runs up beautifully. I take it up flying. I hit a certain RPM, and the airplane just starts shaking like crazy. What the hell is that about? Well, I'd like to see this. So he brought it back in, get in the airplane, take off with them, go flying. We take off, it's fine. We get up to altitude, level off. Yeah, that thing starts shaking. I'm like, whoa, don't do that. Then, Jesus, man. He goes, I told you. I'm like, I believe you. All right, don't, you know, every time you increase the RPM, it starts doing it. Don't do that. Let's go land. Okay, so he lands. I drive him back to the airport, his airport. And, all right, so, you know, what the hell did I do to this thing? So troubleshooting 101 is always, it's either mechanical. Maybe this will take longer than I thought. Mechanical, electrical, fuel, or air. It always comes down to one of those four things. Always, all the time. So, all right. So something's making this thing shake like a dog passing a peach pit when it gets to a certain RPM. So, you know, I think about air. Is the air getting in? Is there, you know, has it got a vacuum leak? Blah, blah, blah. Check all that. Fuels, yeah, fuel flow is fine. You can take off the hose, run the fuel. It's just a little carburetor. You know, got to check through all that stuff. Well, maybe it's electrical. You know, so we end up changing out his electrical harness, new spark plugs. I mean, now we're starting to throw some money at this airplane. And unfortunately, I can't duplicate the problem on the ground. So I got to do something. He's got to come in the weekend and fly it and then come back. Nope, still did it. You know, check that, do this, do that. You know, well, mechanical. What possibly could it be mechanical? I don't know. You know, the piston's connected to the rods, connected to this. Everything is fine. I think I spent a week troubleshooting this thing, maybe 2. And so I'm at the end of my rope. I am just like, I don't know what to do. I am just completely out of ideas. So I go into the cylinder shop, and I'm just sitting there, and it's Tim. Tim's, you know, what's the matter? I'm like, dude, I cannot, for the life of me, I just can't fix this airplane. It is just beyond me. I said, is there anything possible? I mean, anything that you would have done on this 0200 that just isn't standard or something like that? And he goes, 0200. He goes, no, it's a Cessna 140. They don't have 0200s. They have C85s. Like, well, not that one. It's got an STC for an 0200. He's like, oh, dude, I am so sorry. He goes, I thought it was an 85. He goes, I built you up an 85 cylinder. There's one difference. An 02 piston, which I got the right piston, but outside the piston, an 0200 has 3 valve springs, and a C85 has 2.
Give you one extra.
Nope, he missed me one.
Oh.
Gave me 1 spring less. I gave him a cylinder with 3 springs. He gave me a cylinder with 2. So every time we hit a certain RPM, it resonated, and it would just keep the valve open. Sucked. So, I think we lost a customer over that one.